Alright, this is Ms. Haynes. Welcome to my video. I'm trying something new. I'm talking about the three properties that we're using. The associative property says that when you're adding or you're multiplying, the grouping of your terms doesn't matter. So if I've got the quantity 2 plus 3 plus 1, it's going to be the same thing as 2 plus the quantity 3 plus 1. And that's because you're just adding them. If I do 2 plus 3 first, I get 5, plus 1 is 6. If I do the 3 plus 1 first, I get 4. 2 plus 4 is 6. It's the same no matter what happens. We like this because that means that I can regroup terms together in ways that are convenient for me if I need to change what the overarching expression looks like. Okay? Commutative property, that's where the order of the terms doesn't matter if you're adding or you're multiplying. So that's like if I were to say 2 plus 3 plus 1, that's the same thing as 2 plus 1 plus 3. That's the same thing as 3 plus 2 plus 1. Anyway, I write these three terms, and there's three other ways of doing that. 1 plus 2 plus 3. It doesn't matter what order I write them in, because I'm adding all of them. And now we can extend this. Right now we can say, well, if I have a subtraction, if I were to just move this around and say like 2 plus 1 minus 3, that wouldn't be the same thing as 2 plus 3 minus 1. But if I think about this subtracting 1 is the same thing as adding the opposite of 1, well then all I gotta do is make sure this minus sign, the subtraction sign, stays with the 1, and I can move that around wherever I please because I'm adding a negative 1. So I could rewrite him as 2 plus negative 1 plus 3, or negative 1 plus 2 plus 3. This guy, I could just rewrite it around. As long as I keep that minus sign, that negative sign with that 1, I'm good. Okay? And that's really cool. That's something that I don't know if they've done before. Distributive property. You can rewrite a product of a number and a sum as the sum of the products of the number and each addend. What that looks like is if I had 2 times 3 plus 1, that's the same thing as doing 2 times 3 plus 2 times 1. You can think of this as an area model. You can think about if I had a box that's too tall and 3 plus 1 long. Let me write it down because I do have the camera over there. I could do 2 times the 4, or I could do 2 times 3 and 2 times 1. Either way, I'm going to wind up with 8. So this is 2 times 4. And this is, say, 2 times 3 is 6. 2 times 1 is 2. 8 equals 8. It's true. Distributive property is important because right now we're getting into algebraic stuff. We have x's and y's and other symbols that stand in for things we don't know or things that we might want to be changeable, might want to vary them. And so we can't do this right here where we combine everything inside the parentheses first into one thing and then multiply. We can't say 2 times x plus 1. We can't put x plus 1 as a single term. We don't know what x is. We can't add it to 1 and combine it to one term. But we can say, well, 2 times x, that's 2x. And there's a plus sign here. We're going to keep that. 2 times 1 is 2. On that paper, there also is combining like terms and equivalent expressions. This video is about 5 minutes already. I'm going to take a break here, see how this uploads, and then continue. I hope everyone has a great day. Bye-bye.